On behalf of SEAP Executive Council, we welcome you all for today's session on responsible AI. And this talk will actually introduce the subject of responsible AI, showing very specific patterns that can make the AI ML systems more ethical and more explainable. And it's our real pleasure to have Mr. Dattaraj Rao. He's our esteemed speaker. And currently he is working as Chief Data Scientist in Persistent. He is also author of Keras to Kubernetes, and he holds 11 patents in computer vision. So without any further ado, I request Dattaraj to start the session. Just one request to everyone. If you have any questions, please post them into chat window and we'll address them towards the end of the session. With that, Dattaraj, over to you.
Thank you. Thanks, Prashant, for the kind introduction. And hi, everyone. My name is Dattaraj, and thank you to Prashant and the SEAP committee for having me present this session. This is something very close to my heart, the subject of responsible AI. And I hope to, over the next 1 hour, share some of my experiences over the years on AI and how to look at responsible elements like ethical elements and explainability and other aspects. I'm not going to have a lot of technical details. I'm trying to make it such that anybody with a basic understanding of software development will be able to appreciate and understand this. If you know ML well and good, I mean, you'll be able to relate better, but it is not a necessity. So I'll try to keep it very generic. And like Prashant said, keep your questions in the chat and we'll spend a lot of time at the end, maybe less 20 minutes taking questions. So let's get started. And Prashant gave a nice introduction about me. That's my book, which I published I think 3 years back, Keras to Kubernetes. And when I wrote this, it was more this field of ML ops or deploying ML to production standardization was very new. And Keras, Kubernetes were something that were really hot topics. But now I'm seeing this space growing a lot. There are so many open source tools, so many new technologies coming up almost every week, and so much great work that is happening. So this is really difficult to keep up to pace with this technology. So what I'll do here is just talk about some generic patterns at a high level. So you don't need to know any of this tooling or any of the details, but hopefully try to explain the basics of how some of these responsible elements can be applied to AI and ML systems. Before Persistent, I've been with Persistent 3 years now. Before that, 19 years I worked with General Electric. I was with G Power, G Research and Transportation in different roles in Virginia, Bangalore, and other areas. So that's a little bit about me. So let's get to the crux of it. So we'll start with why do we need responsible AI? So I'll show some real world examples of how not focusing on some ethical aspects caused some major issues for some big companies. Relatable examples in the news. What are the pillars of responsible AI that we have been promoting? And you take up any company, Google, Microsoft, we at Persistent, they will all have some guidelines around it, and more of them, more or less, they are very similar. So I'll talk about that. Talk about specifically about accountability, fairness, and bias, which is a big topic of discussion in recent years. Then get into more around the automation, around reproducibility, transparency, and this discipline of MLOps, which is getting very popular. Talk a little bit about that. And then if there is time, actually I may not have the time for the REI dashboard, but I wanted to cover a few steps around privacy. So I have an example of from the REI dashboard. I was going to initially show it live, but I'll just show some examples on slides in the interest of time, so you can appreciate the key aspects of it. So let's get into it. So I'm sure I'm preaching to the choir here. Today, data is the new oil. Most companies are making more money from the data than the actual physical assets. So companies are marketing their data, getting new outcomes from their data. And in this world, AI becomes a new electricity. This is a term coined by Dr. Andrew Ng. So the idea is you need AI to really process this much volume of data, the volume, velocity, and variety of data, the 3 B's that we talk about in big data. You need AI to start analyzing it better. There is only so much you can do with like traditional rule-based or deterministic systems. You need statistics, you need ML to try to analyze the system. But then with great power comes great responsibility, like the famous quote in the Spider-Man movies. So we see these kind of headlines, like Amazon released a facial recognition software, and it was supposed to identify criminals. And then reports found out that it actually mapped some politicians, members of Congress, to criminals. So it was not very reliable. And this was actually even worse because members of certain race were actually targeted even more. We have algorithms being used in loan approvals, in student grading. So these algorithms can get very, especially if you look at healthcare in countries like US, where algorithms are grading your insurance coverage. Then do you want an algorithm to be biased on some non-essential features and make a wrong decision just because of the inherent bias? So this bias is now becoming very prominent, and that is one of the major issues for why we need responsible AI. So there are at a high level, there are two. The screen is not. There are two high-level areas where responsible AI becomes very important. The number one reason, ethical reason, which you see in these sort of headlines. The second, let's talk, before getting into the second reason, let's talk about this one example. This is a famous example of Apple Card. So Apple, some I think 3 years back, 2019, they partnered with Goldman Sachs, and they created this Apple Card. So the idea was this is like another financing opportunity, and it was like a credit card but powered by Apple. So it was more tied to your iPhones and tied to Apple devices. So what happened was, when people started looking at the way Apple card was giving out credit limits, it had a bias on the gender. Steve Wozniak, who's one of the co-founders of Apple, he actually sent this famous tweet where he got a 10 times higher credit limit than his wife. Everything else was same for them, only the gender was different. And just based on that one factor, this algorithm, whoever, whatever was making this decision, gave him a 10 times bigger credit limit. So this became a major issue. It was covered on CNN, and Apple actually withdrew that product from the market. But the key thing was, Apple didn't actually do this intentionally. I'm sure they kind of this was something that was inherent. Like, I'm sure one of the, and we don't know for sure how this model was built, but typically you would look at the data, the historical data of the number of the credit line that was approved, and if historically this data has bias against a particular gender or a race, then that bias flows into your model. So when you're building machine learning models, one of the main things of ML is garbage in, garbage out. So whatever data you feed to the model, the output is based on that particular data. So if the input data has bias, your model is going to have bias. So this is the term that we usually call fairness through unawareness. You don't really consider this. You don't want this to happen, but because the data has bias, you're not checked for this data. This kind of a event can happen. Again, I'm not we don't know exactly how this algorithm works, but typically when you build models using data, this sort of issues come in. So you need to be able to check the data for different kinds of biases. So this was one famous example. The second reason for actually that is making the need for responsible AI a lot in recent years is reproducibility. So if this is a famous research paper from Google, what it says is, and this diagram basically says is, when you're building an ML end-to-end system, the ML code is a very small piece of it. This small black box is your ML algorithm or the code. And today these are very standardized. There are packages available or libraries available where you can just say, based on your features, it will find you the right algorithm. A lot of effort of data scientists goes in configuring the system, in collecting data, verifying, building a serving infrastructure, building monitoring. So these elements become very important. And if you are going to be building custom systems for each of these boxes, then you're building a lot of technical depth. Technical depth, basically, I'm sure the software folks know about this term very well. Basically, you tend to delay a certain thing. You just take something half baked, so that in future you end up fixing and spending more time trying to figure out what the problem was. So when you look at things like serving infrastructure, monitoring, analysis tools, if you are going to build this custom for every ML project, that's going to start building technical depth. So it is highly recommended to look at state of the art patterns for each of these things. Tools like Amazon SageMaker, Google Vertex, these already have this, and even open source tools like MLflow, Evidently.ai, they have these sort of patterns already available in their systems. So you want to reuse certain things in a ML platform, and that is another reason why you need to take a responsible AI look at some of this machine learning systems to make sure that you're not building technical depth and reinventing the wheel, so to say. Another part of this reproducibility crisis is actually, this is a very interesting paper in Nature. There is so much hype around ML. Everybody is publishing research papers, but many times the claims that are done, like you have a accuracy of 95% for something, are not really reproducible, or people don't have the code available. So many times what happens is you just say, a research paper says some code, but you download the code from GitHub and try to run it, you can't really reproduce. There are coding errors, so the code is not really complete. So now many conferences are actually started to take code which is only compilable and which they can reproduce the results. So reproducibility becomes very important both in research side and even in when we look at industry. We want to be able to, because now the number of data scientists in any organization is growing tremendously. So while all these data scientists need to work together, they need common platforms, the standardization, reproducibility, so that we know that our ML findings are reproducible, and wherever there are gaps, we can correct them. So these are two high-level reasons why we need reproduce responsible AI. And if you look at responsible AI, there are many facets of it. So like I said earlier, every company has some principles of responsible AI. You look at Microsoft, Google, Facebook, IBM. These are something that Persistent has been promoting over the last 3-4 years. But essentially, the basic idea remains the same. You need your AI systems to be accountable. You need to have a retraining policy, and you need to bring the human in the loop at the right time. This is something that often gets overlooked. Accountability is like you expect the AI system to be end-to-end autonomous, but very often you don't want it to be that. You want to bring the human in at the right place. If the AI system is sure of a decision, you may allow it to make that. But certain cases, when there are borderline decision, you want the human to be in the loop and retrain the data if the AI is making a wrong decision. Bias and fairness checks become very important. So metrics around bias and fairness, those are also very important for accountability. And I'll show some examples of how to do some of this. Reproducibility we talked about. Now MLOps is becoming a very major discipline. And MLOps, for those who don't know, is basically ML applied to operations. So it's like your DevOps for ML. So just like DevOps is for automating your software with CI/CD pipeline, we have an equivalent process. But the main difference between ML and software, I would say, is this concept of data and experimentation. For software, it's more around the code structure, compilation, and making sure your code is well structured, readable, and optimized. While ML, it's more around you're understanding the data correctly, the right features are extracted from it, and the right outcomes are generated from your ML. So ML ops becomes an alternate discipline, and many times some concepts like CI/CD can easily be utilized in the ML ops space. And then there are few patterns, like I mentioned earlier, like data catalog or model registry. These are something that are very important to try to standardize, and you don't want to reinvent the wheel. You don't want to have your data scientists, hundreds of data scientists sharing CSV files. So you rather have a data catalog where they share from a standard centralized database which can be managed. Transparency becomes very important, and especially in regulated areas like healthcare, banking, you don't want to blindly trust a black box model. You want to be able to understand what is happening under the hood, what decision the model is making, what features it is considering as important. So model explainability and interpretability becomes very important. And just a little bit in detail, typically explainability is a generic term where any ML model you have, you can explain that, hey, my model rejected this loan because your income was below $60,000. So that is explainability, but interpretability gets more into the way the ML model is designed. So explainability can be applied to any black box model, but in interpretability means the model is inherently explainable. So something like linear regression, where you are pretty much telling a y, a dependent variable, as a linear combination of your uh, independent variable or your x's. So you know how much each x is weight. So one x has a weightage of something, other x has a weightage of something. So you know which x has a higher weightage, which x has a lower weightage. So such models are inherently explainable or interpretable. So there are techniques to change your regular black box models into glass box models. So Microsoft has this very nice tool called Interpret ML, which has explainable boosting machines. So I know that this is it can get a lot more technical, but this is a very active area of research where companies are looking for models that are inherently explainable and which can provide better results. And then last two areas which are very important are security and privacy. Security is to make sure your ML model is secure. So there are technologies like confidential computing, homomorphic encryption, which can help you do that. So not just encryption at rest and encryption in motion, but encryption during analysis. That is what can be guaranteed by these techniques. And what is really becoming very popular recently with regulations like GDPR, CCPA, is privacy. So earlier ML models, typically data scientists would freely use the data without any consequences of what was the source of the data or any privacy information of the end user was leaked. But now with new regulations, privacy becomes very important. So there are techniques like federated learning, differential privacy, which can keep the data private, but at the same time consume the data and build ML models. So only the insights are generated, insights are consumed rather than the raw data. And then other areas like secure multi-party compute. So privacy is becoming important. There are some patterns which can help you build privacy in your ML lifecycle. So these five pillars become very important. And and these so you may see different wordings for different in different companies or vendors, but basically the essence remains the same. So let's get talk a little bit about accountability. So accountability talks a lot of in terms of besides the human in the loop, bias in the training data and implementation bias. So bias basically is like some assumption that the model has that helps it make decisions. So bias in some aspects is good. You need a good bias. You need to be dependent on variables which are important, like loan approval. You want to be able to be dependent on income, some expenditure, and these sort of features. But then you may not want to be dependent on things like gender and race. So those become unwanted bias. So you need to be able to check for the kind of bias that the data has. And there are techniques to check for bias. You need to be able to make sure there is no sampling bias or selection bias, where you only select some things that are only select data that supports your hypothesis and do not do any negative sampling. So in that case, you are only going to get get one side of the story, and your model is going to learn that model, because your model only thinks of what the data you have provided to it. So if you select only the positives for it or only the good scenarios, then it will just going to learn that scenario. It will not work in the real world where it will encounter all sorts of scenarios. This GIF that you see is a very interesting statistical phenomenon. I just want to talk about it for a minute, called Simpson's paradox. So the idea is when you have a large volume of data, the overall data, if you look at this overall data in black, shows a downward trend. So if you look at this black data points and a red line, it is showing so overall the trend is downward. But if you look at specific groups, like these groups marked with different color, you're seeing an upward trend. So the trend is actually reversing. The overall data is showing a downward trend, while you look at an individual group, the trend is an upward trend. So this is called Simpson's paradox, and this happens a lot with as you have a lot amount of data. You will actually it'll be very interesting if you should actually try this on your data set and see if you see this paradox happening. And how and what this different color data set is. This is basically groups. So for example, in one of the examples that I read, this could be age. So different age groups will show an upward trend, and the overall data set will show a downward trend. So what this means is age is basically a confounder. So confounder is basically a variable that affects both the dependent and the independent variables. So this X and Y are both affected by age. So such a confounding variable, confounding is a term in causal statistics, and it basically means that this variable of age would be affecting both X and Y. So when such a variable exists and you group by that particular variable, you see this Simpson's paradox. You see that there is one trend when you group it by look at a particular group, while if you look at the entire data set, it's a downward group. So this becomes very important. So the age is very important, or this confounder is a very important variable, and you need to consider it. So when you build ML, you need to pay special attention to this. So this is an example where you would want to look at even before you get into all this auto ML model development and starting to look at building ML, you want to look at how your data is, if there are any paradoxes like this, if there are any, when you group it together, if you see a different pattern and want to make decisions on it. So this is one example. I'll just jump into this, and then fairness becomes very important. And like I said in the Apple example, that was fairness through unawareness. They didn't really plan for it, but it happened. But there are different metrics to help quantify fairness. There is demographic parity, equal odds difference, etc. This is a LinkedIn article. Interest of time, I'll skip this part. But all this metrics of fairness, it is not rocket science. You just need like a true positives, false positive, false negative, true negative from your predictor, and based on that, you will come to know uh, that what sort of a fairness metrics you have. So things like disparate impact ratio, statistical parity difference. This is an Excel sheet. I have made it available on this LinkedIn. It's on a persistent blog post also. You can just try this example out, and you can see that how easy it is to plot these things or calculate these things manually, these different statistical metrics. So that talks about more about accountability. Now let's jump quickly into reproducibility and transparency. Now I mentioned there are today there are, you saw that earlier diagram or the boxes where a lot of effort was spent on non-ML development. So typically you can see four different areas which become very important whenever a machine learning project gets started: data management, model development, production deployment, and model lifecycle. And what I've listed here are these different patterns. Like for data management, you want to be able to look at data ops pipeline. Many of our customers come to us and say data, they have so large volume of data quality is an issue. So we help them try to look at tools which can help measure the data quality and identify problem areas and help them improve the data quality. So data quality analysis becomes very important. A version data catalog is highly recommended in today's ML systems. There are tools like DVC. So these are the some of this open source tooling which have this, like DVC is a very popular tool which can whatever your data sources, your data may be in Google Drive, Amazon, Snowflake, it can put a wrapper on top of it and give you a version data catalog. So whenever you have 10 data scientists working on a data set, you can know which version each one of them is working on and make sure that the data set is consistent. All these hyperscalers that you have like Azure, Amazon, and Databricks, they also provide this feature. So Amazon has a feature store which can help you with data management. For model development, auto ML and low code ML is becoming very popular. Low code ML is actually something that is with tools like H2O, PyCaret, is gaining a lot of popularity, and people are trying to with even with basic understanding of Python, you can, as long as you have a good understanding of the data set, you can build an ML model using these tools, and it will recommend you the best ML model. The only key thing is you need to be able to understand this concept of experiments and track the right metrics for this ML model, so you know which metric is important to you. Production deployment, traditionally your ML model would just be a binary file and your software developer will package it, but that cannot cut it anymore. I mean, we need to have this a version model registry where all these models have different versions, and you need to even be able to do A/B testing where you test two models at a time. You don't, like if you have a like a recommendation model, you don't want your users to be working on a stale model. You want to give them the latest recommendation. So today, even more than A/B testing, there are multi-arm bandits, which is a concept from reinforcement learning, which is becoming popular, where you can test actually 3 or 4 models at the same time. Bandits words comes from the casinos actually. So it's a multi-arm bandit, and each model will give you some sort of scoring. And there is a statistical method where you can, with a limited number of tries, you can figure out which arm or which model is giving you the best return of investment. And finally, managing the lineage of these models, outlier tracking, these things become very important. So this is kind of the focus of reproducibility of ML. So you want to have these patterns. So ideally, we usually for a mature ML customer, we highly recommend a platform, either a open source based platform like you see in the middle box, or a cloud based platform like SageMaker, Azure Data Studio, because these these hyperscalers or these open source tools, they capture these patterns. So you don't have to rework or reinvent the wheel. You kind of apply this data catalog as it is because it comes with this catalog. So this is around reproducibility of ML. So let's see how this would be applied in a real scenario. So this is your traditional ML pipeline. So you would have your ML development environment, production environment. Development, you do data preparation, model development, testing, validation, and then do a deployment where the popular pattern here for deploying models in production is as microservices. So you build model as a service, and then you will have some logging. You will have a monitoring service that will take the input from the logging. And typically you will do a SLA or a service level monitoring. So you look at if the model microservice is up and running, how many requests it is got, was it down for so much, what was the availability. You wouldn't really get into the accuracy metrics, at least most folks don't. And then based on your feedback, you could look at if the service is down, you could reconfigure and retain it. Now let's take the first example of reproducibility. So you could introduce things like a data catalog of where you could catalog this data rather than just like CSV files. You could have a catalog data so you know which version of data you're working on, model registry for model deployment, and a feature store which can help you with which can even have some ways to test your data and make sure the data is in right features. So this could be this some patterns could apply reproducibility to your model. For transparency, along with your metrics, like you typically would look at something like a confusion matrix or a ROC curve. But now you would also want to look at an explanation. So you could look at something like SEAP, which is popular as a black box explainer, and you could see what features the model is taking is more important and are they the right features. You would want to have this validated by a domain expert. And even in production, along with your service level metrics, you would want to look at things like data drift and concept drift. So drift is a very important concept. Many times people deploy models to production, but and they assume that the model is going to be like static, but this is never the case. A model is typically the data will change, the relationships will change. So a model has to be a living and breathing thing. Over time you need to monitor if your data is drifting. So this example you see here, you can clearly just through chart, there is no fancy library here, just through a couple of charts you can see that the before data and after data, there's a big deviation. There is a drift in the data, and so you want to know if your model can handle that drift. If not, you want to retrain it. And then you want to monitor accuracy over time. So you want to look at concept drift. If the concept is changing, the relationship between x's and y's are changing, and then you want to check for the concept drift also. Now concept drift becomes difficult because when you actually want to know if the prediction was right or wrong, you want to give it the ground truth. So tools like Seldon, uh, uh, even AWS SageMaker, they have this way to provide ground truth for certain test results, and based on that you can measure this concept drift. And then finally, accountability becomes very important. This is where you get into human in the loop, studies of causality, bias, metrics, etc. Now, here we highly recommend that you have like an AI ethics committee. It may not be like a big group. Now, bigger organizations like Google have dedicated organizations for AI ethics. But at least you need, especially when you're playing in a regulated field, you want to have an AI ethics committee who makes the decision right from is ML the right thing for this project? Two, is there a bias in the data? What bias metrics are you checking for? Two, once the ML model gives you the results, you bring the human in the loop to validate the results, and at the right time decide that the model performance is failing and you want to retrain your ML model. So all those decisions are need to be validated, and AI ethics committee kind of becomes like the key organization to do this. So this is in a nutshell, just one example of how you could apply these concepts to your existing ML system. So with that, I won't get into the actual demo in the interest of time, but I have just some few snapshots of how an MLOps framework would work. And we have this deployed as a demo. This is a publicly available demo on YouTube. So maybe offline you can have a look at this. These slide materials will be available. So this basically takes to the entire life cycle of your MLOps, and you can see the logo is very similar to your DevOps. But here you are looking at things like exploratory data analysis, comparing if there is a bias in the data. You look at AutoML. So AutoML lets you, like I said earlier, it compares these different models, rich classifier, random forest, logistic regression, and gives you a table like this, that this is my accuracy, this is my area under the curve for ROC curve, recall, precision, and you can select which is the right metric for you. And based on that, you can decide which model is right for your particular use case. This curves, AOC curve is very, very popular. It tells you the predictive power of your classifier. And then you get into explanations. There could be global explanations like this. So global is basically the entire model on a test data set. If you can know which features are being important. But then when you get into regulated spaces, you want to have a local explanation for every decision that was made. You could have a local explanation like this, which will tell you these features, because these features cross certain value, you went into the orange mode instead of coming into the blue mode. So this becomes a very important local explanation. And then as you get into the data monitoring, you want to monitor for drift. This demo actually is a nice example by which shows the COVID scenario. So before and after COVID, you could clearly see the drift in data, and through a simple Power BI based interface, this demo, you can see that there's a data drift happening and how to counter that. So this is kind of this was some a basic. I didn't want to show the dashboard because the demo is already available in YouTube and you will be able to see that. Instead of that, I just wanted to spend the last 10 minutes focusing on a case study on loan approval. So this is something that we had done. This is basically a loan approval data set. There are different features like self-employed, applicant income, co-income, loan amount, etc. And we took two different versions. So we had a data catalog, and we took two different versions of the data. The data was coming from a Snowflake database, and we partitioned two tables. One was feeding one data set, one version. Second was feeding second. And we saw that for the data set version one, we got a decent AUC curve. And AUC curve, for those who don't know, the area under the curve, the bigger the better. The bigger area, that means your predictive power or the classifier is doing a good job. And this was a simple classification if the loan state would get approved or no. And here we got a bigger area for the dataset version 2. We got better results with a random forest classifier. And this was on a publicly available dataset. So we said, hey, dataset version 2 will have a is better. So we should use dataset version 2. But so this is how typically for a new data scientist would approach it. But we said, let's take a step back. Let's look at what the data is saying. So what we did was we did an explainability study, and we saw that for dataset 1, it was taking the right features like credit history, loan amount, applicant income, co-applicant income. These were the top features. So this is bar chart basically is a feature importance chart. It tells you that this feature is more important and in some sort of a scaled importance metric. So we saw that these features, and this is where you want to connect to a domain expert. Now, this is a very simple example. I'm just showing you intuitive features. But in the real world, you will have 200, 300 features. And you would, many times, this will be something.x, something.y. So you want to talk to a domain expert to show them what your model is showing and understand if that is the right thing. So here you'll see these features from a domain perspective make sense. This seems like the right version. But if you look at dataset version 2, gender becomes more important, and this is a red flag. So here what we are saying is this, and relating to the Apple Card example. So an explainability study like this tells you that your outcome depends on a non or a protected feature like a gender, which it should not. So you can get a confirmation from a domain expert if this is a protected feature, and if this is not something that is should be used, then this data set has an issue. So basically this data set version 2 has a bias, and we need to have ways to measure this bias. And one of the ways, so there are some libraries available. Facebook, IBM has a very nice library to measure this bias, but you don't need any fancy libraries. You can just have charts. So we went ahead and plotted gender and married against the loan status, and you can see that the distribution for male versus female, for approved and not approved, is almost the same for gender. But if you look at the gender for the dataset version 2, this is the dataset version 2, you can see clearly when the gender is female, there's a bigger portion which is getting rejected rather than as compared to getting approved. So even without any libraries, without any fancy tools, just through pure plotting, And this you can have even a Tableau dashboard do this plot. You can see that you look at one particular feature of importance which you want to test for bias. You look at the possible outcomes of that feature, and you look at the counts for your target variable with target feature, which is the known status, and you can clearly see if the bias exists or no. And then there are other tools available by which you can actually measure this bias, quantify this bias, and have a metric for it. So this was a quick demo that we had done for to find out if the bias does exist and how easy it is to measure this bias. And then if you have bias, there are tools that are available which can actually help you mitigate this bias. So and yeah, I missed this part. So I'll end with a quick overview, like a 5-minute overview on privacy and security. And this is a topic we can have a detailed separate webinar, 2-hour webinar on. But the idea is privacy of data is very important. So there are techniques like federated learning, which you can train a model in a decentralized manner. Some part of this chart may not be visible, but the idea here is you have data in say 3 different locales. There is a data in America, Middle East, uh, and Europe. Now you can keep the data as it is on the local machine. So data remains on the local machines. You only send this model updates. So this pattern is called federated learning. You have a federated learning coordinator in the middle. You just send your model updates. So for those who know neural networks, when you train the data with a neural network, the weights of the network is what gets updated. That is the intelligence. So what you do is you don't send the data, you train the local model to get the weights for the local data, send the weights, and you do something simple as just averaging it out. So average the weights from the 3 models and use that as a for your model development. So once you do that, you do multiple rounds of such federation, collect weights from different machines. Uh, and so you keep your data private, keep your data protected, it's secure, you're not sharing any data. All you are sharing is model updates. So even if there's an adversary, if there's an attack, they only get model updates. It's very difficult for them to understand what exactly you're sending. And so your training data remains secure, but at the same time, you can build a very powerful centralized model, and that model can be used to make decisions. So this is an example of using federated learning, especially when data cannot be aggregated. So if there is either geographical regulation, you can't move data physically between Europe and USA or India, then this can come in a play. Or if there is a sensitive data, like in one of our customers, it was a patient data. We could not actually share it between hospitals. So we kept the data individually on those hospitals and just shared the model updates and build models. So this is where federated learning can really help, a decentralized way of building ML models. And this is just one solution. There are multiple other ways to build models. But the key idea is data doesn't leave the machine. You have a coordinator wherein the models are developed, and many libraries are available to do federated learning. We actually have a partnership with Flower and IBM, where we work closely with them to build ML models. And this is just a case study that we had done. I won't go into this one in terms of time, but basically for an imaging case study, this is a paper that we have published. We could see that just keeping the data on machines for a medical imaging case study, we got very limited accuracy, but the common FL model got a 14% bigger improvement of the accuracy just by combining. It is basically the accuracy is because of the data, but this is a very smart way of combining your results instead of combining the data and building an ML model. So this is getting very popular. A lot of companies are building business model around this, and we see a lot of growth in this space. So I think I'll stop there. We talked about the 5 pillars of responsible AI, spent a lot of time on accountability, transparency, reproducibility, and then talk a little bit about privacy and security. So I think I'll take a pause and I'll take some questions. I know there's a lot of things. So either now or even offline over LinkedIn or emails or through SEAP, do get back if you have questions, and I'll be more than willing to answer any doubts or spend more time on this. Thank you. So let me, Prashant, you want to take the questions or should I start reading?
Yeah, go ahead, Dattaraj. If you have access to questions, go ahead and answer it.
Okay. Yeah, so this first question from Prashant is so about the AI ethics committee. How important are these groups in the current corporate pecking order? How far is the policy away from what technology through these committees can currently deliver? Yeah, that's a good question, and not an easy one to answer. So initially, I would say till at least 3 years back, we would just have these as documents. I mean, they would just be policy files on, like Google released a nice policy file, Meta released a policy, actually Facebook released a policy file on AI ethics, but not a lot of action was happening. But more recently, I mean, if you look at somebody like Hugging Face, they actually have released an AI license which talks about ethics and accountability. So a lot of actionable items are happening now. Of course, it is not ideal so far. There is a long way to go, but I would say the impact is happening because of these issues that are happening. So companies are realizing ethics is very important, and now a lot of action is happening to actively monitor models and make sure at least the models that are released are screened for this bias. And I encourage you to look at Hugging Face website. They actually are doing a lot of things in. They are releasing models for free, but they have a very good ethics-based AI licensing model. Are policies think tanks considering impeding progress by technologies rather than augmenting? If so, how can this be changed? Yeah, I don't think it is impeding progress. Well, I mean, you can look at a case. I mean, it is like they're stopping the free run. I mean, where you could just take any data, do whatever you want with it, come up with the result. I think there is some sort of a control which is definitely needed, especially when you get into more of regulated spaces. So I don't think they are. I mean, it may feel like it is impeding right now, but I think once the uh, process is set, I think it will benefit the larger. It is better to set it up now rather than once it goes out of control. So I don't think it's going to impede anything immediately. Are there places, groups, or think tanks that truly work at an intersection, or both parties view each other with skepticism? Yeah, that's a that's another like lot of good points here. So skepticism is there, but I would say this is getting better. Like that Hugging Face example, and even the other players, Microsoft, IBM, and Google. I think this is becoming very important, and Google also has. I think Microsoft has a AI responsible AI officer now. So that was something that was published. So they are also starting to take this very seriously. Uh, so yeah, I think it is getting better. On a similar note, which are some? Yeah, this is a good question. I may not have a good answer. Which are some of the groups in India that are influencing this space? I know we do a lot of talks from persistent side, and a lot of our customers come to us as responsible AI actually becoming a major offering, and we are actually getting requests from customers to look at how to build explainability and ethics into ML models. So we are actually, I would say, we do get a lot of this. I'm sure there are every other player in India. You would have this. Uh, because everybody is looking at this as a major initiative and to help the customers build better models. But yeah, I think everybody will, if not now, will soon get into this space, and for the good. Question from Anand Kumar Patel. Based on bias, does human intervention is based on bias? Does intervention is required, or is better to write ML algorithms who will read that bias and provide the relevant solution, or it should be hybrid to have better output? So which approach is fine out of these three options? So I'm just to understand the question. The three options will be, there is one is human intervention, uh, and second is the ML algorithm, and hybrid output. So yeah, I may not have understood it fully, but I mean, if you look at three options, I would say the better approach would be to check for bias in your data. So there are ways, metrics to check for bias in the data, which is taking the human intervention. But once you have metrics, you can automate it. So you can use tools like MLflow to automate your bias measurement. In that case, it just becomes more of a monitoring thing, where once the once the metric falls, when you have a new data set with the metric falls, you would just want to alert the human expert. So I think initially more human intervention is needed, but over time with MLOps, you can actually automate this. So the good thing would be if you can apply MLOps to responsible AI. So if you can, and that's why even with persistent, we have responsible AI and MLOps treated together. While MLOps focuses on automation, responsible AI focuses on ethics and bias. But you want to be automating together. You don't want to just have one doing the human intervention. You want to be able to automate your bias detection also. I hope I answered the question, Anand. From Arpita Kolatkar, how fairness and neural systems, example, gender neural systems, go hand in hand? What is the key difference between fair and neural system? Yeah, a neutral system. Sorry, yeah, I may not know the. Maybe when you say neutral systems, may mean something else. But yeah, I think fair systems would be. I think gender neutral systems is a special system where gender is considered fair. Like you don't have to be biased by gender. So I would say gender neutral systems would be an example of a system where gender bias should not happen. I think that is the way I would interpret this. So if you look at regular systems, and I can't give you an example, but there may be a system where gender bias is needed. So maybe the domain expert tells you that from your system that gender bias is valid and we want to keep the bias. In that case, the ML, it's okay to build ML model with a gender bias. So when you have a specific system called gender neutral system, that means by definition your system does should not have a gender bias. I think that that's what it means. So that would be the difference. Gender bias system would be a special case of your fair system. So I think these four were the ones that I had on the chat. If anybody has any questions, feel free to jump in and I can try to answer.
Okay, so I think Dattaraj, these were all the questions we had. And again, thank you very much for your time. I think it was a very insightful session. And I know each of these pillars are actually a session in itself. So maybe in future, if there is an interest, we can have a deep dive sessions on some of these features. And thank you, audience, for joining this. I hope you enjoyed the session. And Dattaraj, thanks again for taking time out and giving us these insights. Everybody have a good weekend, and thank you very much. We can conclude the session now. Thank you. Bye.
Thank you, Prashant.